In this video, we will be continuing with the West African Senior School Certificate Examination, Chemistry, Paper 3, precisely a test of practical work. Today, we will continue with question number 2. Before we continue, I want to thank those of you who have sacrificed your time to subscribe to our channel. But for those of you who haven't subscribed to our channel, please like this video, share to other learners, and take some time to subscribe to the channel so that all answered questions will come directly to you. Let's get started. Question number 2. G was a simple salt. G was a simple salt. The test recorded in the table below were performed as indicated. Copy and complete the table. A. You have the table there. You have a column for tests. You have a column for observation. You have a column for inference. Now, under this, we have A1. For under the test, G, as we're told, G was a simple salt. G plus heat. On heating a simple salt, our observation is colorless, odorless, gas evolved. On heating salt G, we observe there were after observing it, it was colorless, odorless, and there was a gas that was evolved. Under the inference, it is supposed to be a gas. Could be carbon dioxide, the gas could be oxygen, the gas could be nitrogen, the gas could be helium, and it could be argon. 2. On testing, the gas tested with glowing splint. Gas tested with glowing splint. What was the observation? A glowing splint rekindled. On testing the gas with a glowing splint, the glowing splint was rekindled, and the identity of the gas is oxygen. You know, oxygen rekindles a glowing splint. 3. On heating salt G very strongly, on heating gas C very strongly, gas G very strongly, the observation was there was a brown gas that was evolved after heating, after a strong heating of salt G. A brown gas is evolved, which turned damp blue litmus paper red. Any gas which will turn damp red, a damp blue litmus paper red should be an acidic gas. Any gas which will turn damp blue litmus paper red should be an acidic gas. And among all the gases under the inference column which we mentioned, we said G plus heating was carbon dioxide, um, oxygen, nitrogen, helium, and neon. Neon will not turn damp blue litmus paper red. I mean a helium. Argon will not turn the damp blue litmus paper red. Nitrogen will not do that. Oxygen will not do that. The only gas that can turn damp blue litmus paper red is carbon dioxide. It's carbon dioxide. Now, again, residue was yellow after strong heating of G. There was a gas that turned damp blue litmus paper red. It is carbon dioxide. Now, the residue of G, residue was yellow when hot and white when cold. The residue was yellow when hot and white when cold. What should be the residue? Zinc oxide. A zinc oxide is the one. A zinc oxide is the one. For instance, if you say, look at it, if zinc carbonate is heated strongly. When zinc carbonate is being heated strongly, a gas is being produced, and the zinc oxide is the one that is being formed. The one is yellow and it is white when cold. So zinc oxide is the identity for the residue that is yellow when hot and white when cold is zinc oxide. Let's go to the B section of it. B1, solution of G, that is solution of salt G, plus iron sulfate solution, plus concentrated sulfuric acid. When we react solution of salt G plus iron sulfate solution and a concentrated solution of sulfuric acid, what will be our observation? Our observation will be gray-green. Precipitate of iron oxide are formed. So there are two observations. We will have a gray-green color, a gray-green precipitate of iron 2 oxide that are being formed. A gray-green precipitate of iron 2 oxide that are being formed, indicating the presence of iron 2 ion that are present. Then 2, solution of salt G plus ammonia. Solution of salt G plus ammonia plus aqueous ammonia in drops and then in excess. Okay, on adding aqueous ammonia dropwisely to a solution of G, there was white gelatinous precipitate that were formed. There was a white gelatinous precipitate that were formed. And in adding the aqueous ammonia in excess, the precipitate dissolved. So therefore, the white gelatinous precipitate that was formed on adding aqueous ammonia to solution of salt G indicates the presence of aluminum indicate the presence of aluminum ion. The precipitate dissolving on adding on excess. Precipitate dissolving on adding excess of aluminum, aqueous aluminum to the solution of G indicate that there is the presence of a zinc ion. So the gelatinous the gelatinous, the white gelatinous precipitate are indicating the presence of aluminum ion, then dissolving the precipitate, dissolving in on adding excess of aluminum will show that it is colorless. A colorless solution of ion are formed. I mean, a zinc ion are formed. Now, from all this, name the compound, name G, and write its formula. Name G and write its formula. If you have ever observed the test for cation, with test for cation when reacting substances containing substances or containing cation with sodium hydroxide and aqueous ammonia, you will observe what I am telling you, that when a solution of G is reacted with aqueous solution of ammonia, there is a white gelatinous precipitate that is being formed, indicating the presence of aluminum ion. And when excess of this aqueous aluminum is added to this solution, to this precipitate that is being formed, the precipitate would dissolve. The precipitate will dissolve on adding excess of aqueous ammonia. That also indicates the presence of zinc ion. So, our compound G would be zinc trioxocarbonate 4. The name of our compound G would be zinc trioxocarbonate 4, or what is usually called zinc carbonate. And this is the formula. That is why I wrote here that when zinc carbonate is being heated, zinc oxide is being formed and carbon dioxide is being released. So that is it. Thank you very much. We will do more. We are going to be doing many more examples on this qualitative analysis, and you'll be versed with it. Thank you.